My name is Dr. Levitan. I'm an emergency physician, and I've spent 30 years fascinated with the subtleties of direct and video laryngoscopy and tube delivery. We currently have a mix of devices that we use to expose the larynx, including conventional curved blade laryngoscopes, conventional straight blade laryngoscopes, conventional shaped but video laryngoscopes, and then also hyperangulated video laryngoscopes. In order to assist with tube delivery with all of these devices, we have acquired a collection of different aids to help with tube delivery. We have conventional malleable stylets, which we typically shape into a straight-to-cuff shape. But we also have tube introducers, 60 centimeter long bougies, and lastly, hyperangulated video laryngoscopes, which are intended to be used with hyperangulated blades to help get around the curvature of the tongue and introduce the tip of the tube into the larynx. The challenge when it comes to tube delivery with standard Macintosh-shaped blades is that we have a restricted field of view. Historically, tracheal tubes have a curvilinear shape, and this curvilinear shape is intended to sit inside the patient in a anatomically correct manner. But as we look down the long axis of a curvilinear tube, it has a lot of side-to-side dimension, and as we place it, this distal third of the tube can block the line of sight to the target. Sir Robert McIntosh appreciated that when it came to tube delivery, it was advantageous to use a narrow access tube introducer, what commonly became known as a bougie, with an upward distal deflection. So this became easier to use and to visualize going into the trachea than a curvilinear tube. On the American side of the pond, people began to develop malleable stylets. Malleable stylets that would allow straightening of a tracheal tube, taking it from a wide side-to-side curvilinear dimension to a long, narrow axis with a distal deflection, similar to the overall longitudinal axis shape of a bougie. But the advantage of the bougie is that it has a 5 millimeter outer diameter versus a 10 millimeter outer diameter of a tracheal tube with a stylet. So I'm just going to show you the insertion of these devices. As we do curved laryngoscopy, I'm scissoring open the mouth. I use my first and third digits to do that. I grab the laryngoscope with a very light grip. I come down the curvature of the tongue. I'm looking to identify the uvula. And once I find the epiglottis, I then go from my midline position towards the right side of the mouth. That way the Macintosh blade is keeping the tongue to the left, and we have opened up the right side of the mouth for tube delivery. And the reason why we use the right side of the mouth when we're placing the tracheal tube is because the dental arch comes down, and that allows us a little pivot space with our relatively straight devices. And we want relatively straight devices because we're creating a relatively straight line of sight towards the trachea and for tube introduction. So with a standard stylet, we would introduce the stylet, we introduce it below the line of sight, and then we pivot it in this right corner. As we visualize the target, we pivot and we come up over the interarytenoid notch and then insert it, and we rotate it rightward so that the tube changes its orientation. If we look inside the trachea here, we have this upward facing distal tip, and you can see it there running up. As I rotate this tube towards the right side, you can see that it now runs down. So whenever we insert anything rigid into the trachea, it's a good idea to rotate it to then follow the downward deflection of the trachea, which follows the thoracic spine. When we use a bougie with a curved Macintosh blade, or standard direct laryngoscope, we're holding the bougie back. We don't want to hold the bougie here. One of the problems with a bougie is that people grab the bougie or a tracheal tube too close. And then as they move their hand back, what happens with the bougie is the tip rotates over. And this is a design flaw of traditional bougies. Their cylindrical shape means that if the operator lets go of the device, it tends to roll over. And then you don't know which way the tip is pointing. And that's a big deal because when we encounter an epiglottis-only view, it's critical to know that the tip of the device is pointing upward, going into the trachea, not pointing downward, and it can rotate off to the side. So historically, I started to bend my bougies in half to aid in knowing which way the tip is, but many people have problems controlling the tip of the bougie, especially if they're moving their hand while maneuvering it into place. The other issue that I find with a bougie is that as we place a bougie into the airway, the proximal end of it is up towards the operator's face. Now, traditionally, the use of bougies involves a second operator. In fact, for that reason, because you have this long proximal end of the device that the operator has to not get injured by, but also because you want to place this into position, feel the tracheal rings, place it into position, and then you're going for a tracheal tube, so you're letting go of the device. Now, one way around that is to actually use the bougie and then pass it to your laryngoscope hand, stabilizing the device with your left, and then taking your tracheal tube that you then railroad down the bougie. And again, as we insert this, there is a rotation we want to do here with the tracheal tube, and this has to do with the way the bougie the tracheal tube overrides the bougie, but we want to insert the tube counterclockwise as we place it. Again, many institutions that use bougies have a protocol with 2 operators, 4 hands, to aid in bougie placement because of some of these issues around tube delivery with the bougie. The USB is a unique product in that it is the first device intended for tube delivery regardless of blade shape or video or direct. So it can be used with a direct laryngoscope, a Macintosh shape. It can be used with a video laryngoscope with a conventional Macintosh shape, or it can be used with a hyperangulated blade. And because of its unique features, we can adapt its use for the proper device. So with a standard conventional laryngoscope, we would keep the shape of the device like so, using it as a bougie. However, if we wanted to use it as a stylet, we would place the tracheal tube over, and we can then shape the malleable tip of the USB to be used with a direct laryngoscope. An additional feature of the device is it has its own built-in stopper, which is this tapered tip. So if we were using this with a direct laryngoscope, we would go like so. But if we were using this with our video laryngoscope, we could do the same shape, but with a hyperangulated blade, the device is stiff enough to allow us to hyperangulate the distal tip so that we can match the shape of the blade we're using. So the USB is intended to be used as a tube delivery aid across any device, video or direct laryngoscopy. Its other advantages are it mechanically amplifies the tracheal rings and the feedback that the operator gets. And that happens because of special metal segments here and here, which as the device bounces on the tracheal rings, amplifies the tactile feedback back to the operator. And additionally, unlike a traditional bougie, the USB comes out of the package in a much smaller footprint, so it can be easily stored in airway storage devices. Because of the shape of the hyperangulated blade, the manufacturer designed a rigid stylet to help follow the curvature around the hyperangulated blade. So a tracheal tube gets loaded on, and under view on the video monitor gets positioned into the trachea. However, it cannot be fully inserted into the trachea because of its long access dimensions. And so as we come around with this device, we can see it come up over and enter the larynx. However, as it does, it is going up in this direction, and the trachea axis itself is going down. So the recommended use of this device is to pop it up and then try to advance the tube down while popping the stylet out. Another opportunity to try to overcome this mechanical problem is to rotate it, which then changes the orientation. But this side-to-side dimension of the device is what is problematic. It's too big. It's 3 inches, which is necessary to get around that curvature of the blade, but it's too big for insertion into the trachea. Finally, another issue is the optical blocking created by the overlying tracheal tube and the rigidity of the stylet. That as we introduce this into the mouth, what happens is the tube travels in front of our video element, and it can block the line of sight to the target. So you always want to try to keep this lower down and see it come up over the notch and enter the larynx. However, it becomes difficult given the rigidity of the device, and in many patients, this becomes a problem that you can see the target, but you can't deliver this rigid device accurately into the trachea. The USB, on the other hand, overcomes this in a number of fashions. So we can take the USB and using it as a bougie to augment video laryngoscopy, we can give it a slight bend. So that slight bend gives us enough up direction rather, to follow the blade. So we can get to a shape that is similar to the rigid stylet, but it's not going to injure the patient because it's softer, but also because of its ability to unbend and relax as it goes in, it can actually be inserted into the trachea. This is a novel use of video laryngoscopes with a hyperangulated bougie use because of the USB's unique malleability in its distal section. So as we go in with the video laryngoscope, we've got the uvula, we've got the tip of the epiglottis, there's the hint of the notch, and I'm going to follow the curvature of the blade down. I'm going to pivot it, and notice how small the optical element is here, just compared to our rigid stylet, which I showed you a moment ago. But one more time, see how much space this takes up on the screen, and it can easily block the target, whereas our hyperangulated bougie USB use does not block the target. So we come up, and I can feel the tracheal rings, and if there's any resistance, a slight rightward twirl changes the deflection, allows it to drop in easily. So unlike a rigid stylet, which cannot be fully inserted into the trachea, using the bougie with hyperangulation to follow the curvature around, I can fully insert into the trachea. I can pass it off to my own hand on the left hand, which is holding the video device, and I can take the tracheal tube now, and I can railroad this down the way we do regular bougies. And as I approach the larynx, I give it a counterclockwise twirl, and then I place it to the proper depth, which in a male is 23 centimeters. I stabilize it, remove the video laryngoscope, and the bougie comes out. So the USB, in this instance, is functioning as a hyperangulated tube delivery assistant without the risk of puncturing the hypopharynx and injuring the trachea the way a rigid stylet can, and it provides easier optical visualization of placement into the trachea compared to the standard rigid stylet. I hope you found this presentation covering the complexities of tube delivery helpful, and I hope you find it helps in meeting the clinical challenges of airway management.